Hello everyone, welcome to your statistics online class. Last week we talked about box plots as well as percentiles, quartiles, and even before that we talked about stem and leaf and dot plots. So this is all one chapter. We're going to finish the chapter today. We're going to talk about skewness and bivariate data. So starting with skewness. Skewness is looking at a shape of the distribution. The shape of the distribution can be symmetric, like our face, for example, is symmetric. It's symmetrical. We have one eye on each side of the face. We have one ear on each side of the face. Symmetric is a distribution shape that looks similar on both sides of its middle. If I scroll down over here on the very left side over here, you see a symmetric distribution. If you look at the middle of the distribution, somewhere around 45, both sides, left and right, do look similar. Other shapes of distributions might be skewed a little bit. They might be extended either on the left side or on the right side. So we can have either positively skewed distribution or negatively skewed distribution. Like a positively skewed distribution, the second on the left, as you see, most of the observations, as you see, are on the left side of the middle. Somewhere under 3,000, we have a lot of observations over here. That's why frequency on the vertical axis is quite high. The green line goes quite high on the left side. The observations on the right side from the middle are stretched. There aren't many observations on the right side. There are few observations on the right side, and they are stretched further along the income levels on the horizontal axis. So this green line goes down, so the frequency is lower. There are not many observations there, and they are stretched. The green line stretches further to the right side, so that is a positively skewed distribution. The opposite to that is, of course, the negatively skewed distribution, the third one from the left. And a strange one is a bimodal or bimodal distribution. Remember when we talked about measures of location for distribution, basically different kinds of means, different kinds of averages, right? There is a simple average, there is geometrical, geomean and stuff like that. One of them was mode. Remember, mode is simply the most common observation, right? So here, for example, on the very right side on the distribution, we see two observations. The one that is quite far on the left and the one that is quite far on the right. The two peaks of this green line are two equally highly common observations, right? The frequency for those is pretty high. The vertical axis shows frequency. So we have two modes for this distribution, as you see. So like a bicycle, bimodal distribution is a distribution with two peaks, two modes. And the way we look at skewness is we generally compare mean and median. If mean is equal to the median, then we have a symmetric distribution. Again, as you see over here on the very left side, both mean and median are equal to 45. If they're not equal to each other, then we have a little bit of a skewness in the distribution, right? And so, for example, for the positively skewed distribution, mean is greater than the median, as you see on this left side, second from the left. Mean versus median, they're not equal to each other, and mean is greater than the median. The opposite is the case for negatively skewed distribution. And bimodal, as we said, shows two peaks in the distribution shape. So how do we actually calculate the level of skewness? Well, we're going to use a couple of different formulas for that. The relatively common formula is the Pearson coefficient of skewness. Here's the formula. And of course, in Excel, we have the software option, which is not a Pearson coefficient. So that's a little bit different formula that Excel uses. You don't really need to take note of this lower formula at the bottom, because if you simply hit equals, skew, open the brackets and enter all the observations into the formula, the Excel will give you the software answer to the coefficient of skewness. But if your exams require calculating Pearson coefficient of skewness, you do need to take into account, take a note of this formula over here at the upper right. because again, Excel doesn't really have a separate formula for Pearson's coefficient of skewness. So take a note of this formula, where X bar is the mean, median is the median, of course, the small s is the standard deviation. We'll have a look at some examples, so no need to be worried right now. Now let's have a look at this example. Say we have 15 observations and their earnings per share in 2018. Here are the observations. Let's find the mean, median, standard deviation, and let's calculate both the skewness coefficients, the Pearson and the software coefficient. And let's also try to see whether we have any skewness there. So what can we say about the shape of the distribution? So let's jump into Excel. We have our earnings per share, 15 observations over here. So let's calculate the mean, median, standard deviation. That's relatively easy in Excel. Let's just say mean here, median here, and standard deviation is going to be placed over here. Mean is a simple average. Hit equals, type average, open the brackets, enter all of this data into your formula, close the bracket, hit enter, very easy. The mean is 4.95 cents in earnings per share. Median, very easy in Excel, equals, median, open the brackets, again, enter the data over here. And we see the median is actually smaller than the mean, then perhaps there is some skewness in the data. We'll have a look at the skewness coefficient soon. Let's have a look at standard deviation equals stdev and dot, and we've got a couple of options over here. Remember from a few weeks ago, P stands for population and S stands for sample. In this case, we're looking at earnings per shares for some companies. And the question is it the whole population of all the available companies in this country or in this industry? Perhaps not. I don't think there are only 15 companies in a given country. So we are looking at a sample rather than population. We're going to choose S here. stdev.s, open the brackets, supply the data, hit enter, very easy, standard deviation 5.2218, let's say. Next, let's look at the skewness coefficient as according to the formula from the software. For that, just equals skew, open the brackets, again, supply the data, and done. We see a skewness coefficient of 0.973, let's say, or 0.9734. And Pearson skewness coefficient have a couple of typos here as well as here as well. Skewness, okay. Let's go back to our formulas. Again, I don't force you to memorize the formulas. In the modern age, you can always find any formula you want on the internet. The main thing from these courses is you need to understand what you are doing so that you understand the questions on the exams and apply the correct formula. So for the exams, as you know, you will use your formula sheets. So what we have is 3 times the mean minus the median divided by the standard deviation. That's going to be equals 3 times the difference between mean and median divided by the standard deviation. And we got a skewness coefficient of 1.0173. Now, how do we understand these numbers? Well, if the data is positively skewed, the answers for these coefficients are going to be positive. And if the data is negatively skewed, the answers of these coefficients are going to be negative. And if the data is symmetrical, these coefficients are going to be relatively close to 0. So these ones, somewhat positive. So the conclusion here is that the data is a little bit positively skewed. Not extremely, but it's a little bit skewed positively. And actually, if you make a chart, say a bar chart of these earnings per share or a histogram, you'll see something like this. As you see, a lot of the observations are under $1, so this bar over here, under $1, is quite tall, and there are fewer observations stretching further to the right side. There's only one observation only, as you see, around $16. That's 15 to 16. That's the height of the bar over here on the very far right. So we see data is positively skewed. The slope is more to the right side. And a box plot as well. If you create a horizontal box plot, this is what you will see. Most of the data is on the left, but there is a whisker, like cats have whiskers, that stretches far to the right. That's also how a positively skewed distribution would look like, a shape of a positively skewed distribution. Our next topic is bivariate data, bivariate data. So far during this course of Statistics 1, we've been talking about univariate data. That's basically the data that consists of one variable only. For example, this earnings per share, as we see here, this is only the data on earnings per share. There is nothing else here. Or in a lot of our previous examples from many weeks ago, we had your student grades. It's only the data about student grades, nothing else there. We didn't have the data on, let's say, the numbers of hours that students spent studying versus the student grades. That will be bivariate data, because we have two variables there, amount of time spent studying and the grades. Or in this example, if we add here, let's say, advertising budget, the amount of money spent on advertising, if we enter some numbers here, then we will have this bivariate data. Then we can actually maybe look at the data to try to make some conclusions. Do the companies that spend more money on advertising actually have more earnings per share? I would be able to look at these sort of questions, try to answer those kind of questions. So this is bivariate data or bivariate data. It's a data that looks at a couple of different variables. For example, another example here is looking at home prices versus the home size, the area. And we can look at the relationship. I'm sure that the relationship between the size of the house and the price will probably be positive. A bigger area will likely mean that the price is also higher. And very interesting thing is, how do we actually put the bivariate data on a chart? A usual chart to use for bivariate data is a scatter plot. A scatter plot is a chart that puts one of the variables on the x-axis and the other variable on the y-axis. One of the variables will be on the horizontal axis, another variable will be on the vertical axis. And then we might actually find some relationship between those two variables. As in this case, no, this actually doesn't work. We don't have bivariate data there. I was going to look at horizontal and vertical axis there, but we don't have much on the vertical axis in those examples, only the frequencies. So let's come back to our example over here and create some advertising budget over here. Random numbers anywhere between, say, 3, perhaps that's in millions, 3 million and 9 million for, say, these companies. Let me have, okay, something like between 6 and 12 for, let's say, these companies. Okay, so let's say we have this data for the advertising budget and earnings per share. Let's have a look at the scatter plot. Just select the data. You can also include the names of the variables. And in Insert, go to Scatter over here, a scatter plot. And this is our data. Excel will automatically put the name of the variable on the vertical axis at the top over here for the name of this chart. But let's say, for example, I want to have advertising budget on the horizontal axis and the earnings per share on the vertical axis. Let's say I want to see how advertising budget affects earnings per share. If I spend more money advertising, will I get more earnings per share? I'm not looking at the effect in the opposite direction. I'm looking at how advertising budget affects earnings per share, not the other way around. I think in that case, what you can do is just right-click anywhere on the chart, select Data. Then in the new window over here, select Edit. A new window, small one, will pop up. The name, you can enter any name you want here. For example, I'm going to say that it's going to be called earnings per share. Now for the x-axis, what are the values I want to have on the x-axis? Click here. I actually want to have the advertising budget on the x-axis, so I'm going to select the data only without the net. First delete everything that I had there before, then select this x-axis data. For the y-axis, delete everything that I had there, then select the data that I want to have in the y-axis and hit OK. Hit OK. Let me get rid of this legend over here, so go to Layout, Legend, and None. Because the legend just repeats the name of the chart, I don't need repetition. Here's a nice chart that I have. It shows advertising budget on the x-axis and the earnings per share on the vertical axis. What I could actually do as well to make sure everything is very clear is I could add the names of these axes. Go again to Layout, Axis Titles, Primary Horizontal Axis. Let's call it what it is. That's our advertising budget. Okay. And for the vertical axis, I could give it a name as well. Vertical axis, which is earnings per share. I'll just enter it as EPS. Now everything is clear about this chart. I wouldn't get confused at all. And what do I see here? What I see is usually as I go further to the right side of the chart, these dots actually go higher. So usually when advertising budget increases, earnings per share increase as well. That means that there is a positive relationship between advertising budget and earnings per share. But there is something to be careful about. As I say over here, caution, if you change the scale of the axis, you might think that this relationship between advertising budget and earnings per share is either stronger or weaker. Going back to Excel, if I, for example, squeeze this chart a little bit, you may think that, wow, when advertising budget increases just a little bit, earnings per share, they increase really, really fast because these numbers, they rise very quickly. Whereas if I stretch the x-axis, I might actually think that the opposite is the case. So when advertising budget increases a lot over here, from all the way on the left to all the way on the right, EPS only rises slightly. So don't be confused by stretching and squeezing of the axis. You actually need to read the actual numbers, right? So I'm going to be aware of that. And as you know, the chart, such as a scatter plot, can show you whether there is a positive relationship between the two variables, because it's bivariate data. Like in this example, again, when the dots go from the bottom left to the upper right side of the chart, usually there's a positive relationship. When the dots go usually from the upper left to the bottom right, that means there's a negative relationship between these two variables. Okay, like over here, odometer shows how far the car has traveled versus the price of the car. If the car has been used more, the odometer on the car will show greater number. That will actually mean that the price of the car would generally be lower. Negative relationship between the x-axis, the variable on the x-axis, and on the vertical axis. And if you see some scatter plot like this, where you don't really see a clear direction of these dots. Are they going from the upper left to the bottom right, or are they going from the bottom left to the upper right? They're just like don't see a clear direction. Then it means that there is no relationship between these two variables. The height of the worker doesn't really have any connection to the salary. So a scatter plot would look like that without much clear direction. Here's another example of a scatter plot. Tell me, what do you think? What we have here is the data on car sales for car sales agents. On the x-axis, on the horizontal axis, we have the age of the agent, and on the vertical axis, we have the profits that these agents make from selling the cars. What could you say about the relationship between the age of the agents and the profits they create, they generate? Well, do we see any kind of direction within these dots? It's more or less like a stain, like a circle. So we don't really see a clear direction in these dots. Generally, would say that we don't see any relationship between age of the agents and the profits that they generate in this example. Sometimes, to help you with the conclusion whether there is a positive or negative relationship, you can also ask Excel to add a trend line. Okay, so let's try to do that. Over here in our chart, we can go to the top over here to the layout. That's layout over here. Click anywhere on the chart and click on trend line. Let's, for this course, just stick with the simplest linear trend line, just a straight line. And that can also help me see if there is any relationship. The trend line is up, so there is a positive relationship in this case between advertising budget and EPS. For the case of no relationship between the data over here, as in this example between age and profits per vehicle, Excel might actually give us a trend line that is maybe a little bit positively sloped, going from, let's say, 1,500 on the right, on the left, up to, say, somewhere around 2,000 on the right. So even if the trend line is either a little bit positively sloped or a little bit negatively sloped, this small degree of the slope might not really have much meaning. Okay, so it's usually when the slope of this trend line is greater, that's when we do have a meaning, and there is a positive or negative relationship between the variables. In this case, income and expense, income and expenditure. If your income is greater, you would usually have more expenditure on a lot of different things because you can afford more of those different things. So a positive relationship there. And lastly, for bivariate data, remember the scales of our variables. So far we've looked at numbers, but sometimes the variables might only have ordinal scale. Say, how good is the sales agent? Perhaps we have sales agents that are below average and sales agents that are above average. We don't give any numerical measurements for those. Those are just ordinal level data. In that case, of course, we cannot really put it on the chart. So another way to illustrate this sort of bivariate data is with a contingency table. Contingency table, right? So for the contingency table, we'll put this ordinal data on in one of the columns, and the rest of the observations, they go in the rest of the columns. Say in this case, you own a car dealership and you have 4 locations for your dealership. One in Kane, one in Olean, one in Sheffield, and one in Tianesta. And you have a number of observations for each of your multiple agents in these car dealerships. And let's say, for example, you look at how many dealers within these dealerships have profits above or below the median. Okay, so for example, in Kane, there are 25 dealers with above median profits and 27 dealers with below median profits. In Olean, there are equal number of dealers with above and below median profits. In Sheffield, There are many more dealers with below median profits than above median profits, and so on. In this case, you might be able to see which of these dealership is doing better than the rest. For example, Sheffield here is doing really poorly because a lot of the agents in Sheffield are below the median with their profits that they generate selling cars for you. Whereas Tianesta over here is a relatively highly ranked location because many agents there make above average or above median profits than below median profits. Looking at Kane in this example, 25 out of the total of 52 agents make profits above the median. That's 48% of agents make profits above median. That's relatively good, not too bad. So this is one other way to illustrate what's happening with bivariate data when the data is of ordinal scale or of ordinal level. So what have we learned so far? We've looked at our skewness coefficients. Remember, we've learned two different types of skewness coefficients, Pearson coefficient and the one provided in Excel, the software solution. And today we also looked at bivariate data, specifically scatter plots and contingency tables.